This is Pre-Algebra, lesson 4-1, dealing with ratios and rates. All right. This is page, I believe, 160 in your textbook. Okay, for reference. The first thing we should do is we should basically identify the difference between a ratio and a rate. And we can do this by looking at the definitions in the text. Their textbook gives you plenty of great resources to identify key concepts. So what are some things in your textbook that you should pay special note to when you're trying to figure out an idea? Okay, look at your textbook. Should be open to page 160. What are some special things you should pay attention to? Liam? The highlighted words. Okay, so highlighted words are new vocabulary. These are vocabulary words that your high school teachers know that you've been exposed to and will expect you to be able to understand and define. So these are important things. What else? What else is important? What kind of things? Yeah. The bold words, okay? What else is really important, okay? Usually they try to make it pop out of the page, okay? What else is important? Yeah. Liam. The key concept box. If it's in a box, ladies and gentlemen, it is most likely super important. Which means, okay, that if it's in a box, okay, that you need to pay attention to it. Okay, so if I put Liam in a box, that would most likely mean he's important. Okay, so need to pay attention to him. All right, that's why they make, cages at a zoo. You put them in a box, it's probably important. You want to draw their attention. Okay, so no, probably not. Bad example. All right, so here we go. A ratio. The key idea behind a ratio is it represents a comparison. Go ahead and write that down right now, okay? And I'll write this down in our notes. A ratio represents a comparison. Sure. And I should say represents a. Ratios represent. Boy, I'm all over the really bad spelling. Yeah. Represent a comparison. What about a rate? What does it say about a rate in your book? Okay, Kennedy? Okay. So ratios represent a comparison usually of two things with the same unit. A rate, Kennedy, is different how? They must have different what? Yeah, very good. Okay, so rates represent comparisons or represent a comparison involving different units. You could, in some ways, say that a rate is a ratio, but not the other way around. Okay? Ratios are a comparison, but when it involves different units, we call that, it's a special type of ratio we call a rate. Okay? So it's almost like a subcategory of a ratio. And so because that is the case, I'm going to go ahead and just move it down a little bit. And I'm going to kind of put an arrow to represent that it's kind of like a subcategory. Ratio, or a rate, is a special type of ratio involving different units. Can any of you think of a common rate that we use in our day-to-day lives? Yeah. Okay, for hotels. So a hotel rate might be, it's $100 per night. What are my two units? Yeah. $100 and and nights. Okay, those would be 2 units. There's another one. Yeah, miles per hour. That's what I was thinking. Or if you have my old vehicle, the vehicle I used to own, it was in kilometers per hour because it was made in Canada. And so it wasn't made in America, so they didn't have miles per hour. So I had to convert on the fly as I was driving. Okay. I know the conversion between kilometers per hour and miles per hour in my head. You had to, so I didn't get speeding tickets. It does not take too much math. It is fantastic, but it's great when you're traveling 120 kilometers per hour, which is the highway speed, and your friends think you're going way over the speed limit. They're freaking out in the back of your car. Fantastic entertainment. No, they just didn't know that my speedometer was in kilometers. Oh, no. It didn't say it very clearly. No, they were looking at it, and they were like, you could see him in the rearview mirror. They're like, oh my gosh. You could see, I watched him. Does he know? Does he know? Does he know he's going 120 miles? They're looking around. They're like, are there any police cops? You know, and they're just looking around. They're freaking out. That's great. Okay? So we have ratios and rates. Both of these ideas are important, especially when it comes to conversions. I'm gonna put this little plug in there, okay? But then we're gonna kind of go back to a ratio. When you get to high school, there's a particular process that science teachers want you to know. It's called dimensional analysis. It's a way to convert numbers from one unit to another using a process that is relatively simple. To understand that process, you have to understand ratios and rates to the T. This process is really important to doing well in both chemistry and physics, one of which, or both, you will take in high school. So one of the things that's really important for me, especially being a former chemistry and physics teacher, is that I explain this idea well. And one of the things we will do in this unit is we will do some of the same conversions you will do in high school, okay, though not to as advanced a level. Okay, so we'll introduce some of these ideas so that you've seen them. Trust me when I say you will have an upper hand or an advantage if you learn how to convert now and not in high school. Okay, if you understand it going into high school, you will be better off. And you will then have a better chance at getting a better grade. And your grades in high school matter considerably for your high school or for your college education. For your career, yes. Okay. Full ride. You can get a full ride. All right. Let's start with a simple example of a comparison. Okay? Because in order to use a ratio or a rate, we need a comparison. So let's go ahead and we're going to zoom out here a little bit. Let's make a comparison. All right. You should know that I am 5 foot 11 inches. Okay? I am 5 foot 11. I never made it quite to 6 feet. What we're going to do today is we are going to compare my height to one of your heights. Okay? So, Landon Smith. Okay? Okay? 3'2". Okay? Shh. Hey. First of all, you are 5'3". Okay. 5'3" inches. What does the little single dash represent? Feet or foot. And what do 2 dashes represent? Inches. Okay, when you are measuring something, or if you were to read, let's say, a blueprint, or if you guys were to take a CAD or any kind of architectural design class in high school, I took both computer-aided design and architectural design. If you take these classes, these are common ways in which we represent measurements. The reason it's so useful to us instead of decimals or whatever is because it directly translates to rulers or any sort of measuring device. It's much easier for a contractor, somebody who's building a house, to see this and then use a tape measure to measure that than to see 5.92 feet. Because 0.92 feet is not represented on a measuring tape, a device that a contractor uses to measure lumber and make calculations. So this is a kind of a what we call a notation that's useful in real life. However, for our purposes, for our comparison, we're going to take this and we're going to convert it into a mixed number and then into a decimal. Okay? So let's go ahead and start this process. 5 feet 11 inches can be written as a mixed number. Okay? Does anyone want to take a try at what they think that mixed number might look like? Casey? That's perfect. Yeah. Okay? So it's 5 feet and 11 out of 12. Okay? This would be 11 inches out of a total of 12 inches. This is exactly what we were looking for. Okay, how would we convert Landon Smith's measurement then into this same sort of format? Liam? 3 out of 12. Technically, we could simplify that as 1/4. Yep. And so it'd be 5 1/4. When we're doing this, we should include units. So these are in units of feet. Okay, so 5 3/12 are 5 1/4 feet and 5 11/12 feet. You can also see why contractors don't like this method either, because this is easy. Feet and inches. If I take out a tape measure, I can measure feet, I can measure inches. This is not quite as convenient, but for our purposes, it is good because we can then get it down into what I'm hoping to achieve, and that is a decimal. Okay? How do I convert these numbers into decimals? Okay? David. Okay, I can divide the top number by the bottom number. So the next step in this process, Kennedy, please take out your calculator, is to convert this 5 into a decimal. So we know it's going to be 5 point something, and we know this one's going to be 5 point something. Now, Landon Smith's is pretty simple. Does anyone know what the decimal is for 1/4? Kennedy? It'll be 5.25, okay? So that one we can actually pull from memory. Yeah. $11 divided by 12? I'll do 11 divided by 12. Do it real quick, Casey. Okay, 0.9166666666 repeating. Well, the 7's only because your calculator has a limitation. Yes, so 0.92. Yeah. Shh. Now, something you should know kind of as a review from our last unit. Liam, if we have a repeating decimal, is that rational or irrational? There's a pattern involved there. If there's a pattern, it's rational. Very good. If there's a pattern, it's rational. If rational means it can be written as a fraction. So, because 11/12 can be written as a fraction, it is indeed rational. However, what if there had been no pattern? What if it had been a random set of numbers after the decimal? Yeah. It would have been irrational. Okay? So we're trying to identify patterns. All right. Not too bad. I'm making a comparison between Landon's height and my own height. Okay? So we're working towards figuring out what this ratio should look like. This is where we turn to our textbook and we say, what is the key concept? So we're looking for that big rectangular object we call a box. And how many different ways can you write a ratio? Kennedy. You can write a ratio 3 different ways. You can write a ratio 3 different ways. Okay? Let's go ahead and write that ratio using our numbers up on the screen. Okay? So the first way we can write a ratio, okay, is to use the word to. So I could say 5.92 feet to 5.25 feet. That would be the first way I could write a ratio. Depends on how you're comparing it. It could go either way. It doesn't necessarily matter, but I'll tell you what I would like you to do in just a minute, because we're going to look at the fraction in just a little more detail. The second way you can write a ratio is as a fraction. So let's say 5.92 feet, 5.25 feet. Okay, so we can write it as a fraction. Is this a rate? It's not a rate because why? It's the same units. So I'm going to make a little note here. This is not a rate. Okay, this would be just a regular old ratio, a regular comparison. Had it been feet to inches, would have been a rate. But it's not. All right. 3, we can use a colon, so 5.92 feet, colon, 5.25 feet. Yeah. Notice the 3 ways that we break this down. We have the word to, we have the line separating the values, and we have the colon. These are the 3 ways to write a ratio. Where do we use ratios in real life? Of all of the ideas that I'm going to present to you, I will tell you this is one of the most applicable. Yeah, which means that you'll see it the most. Okay, sure. If you're explaining groups and you're saying, hey, there's a ratio of 3 to 4 guys to girls or girls to guys, that would be a ratio. There would be an example of ratios would include a comparison on the stock market. Maybe your parents work in stocks and bonds. Maybe they have to compare quarterly trends. For instance, Google, okay, every quarter, every major public entity, including Lutheran Health and all the others, they have to publish their quarterly financial report. Okay, this is required by law. So they go ahead and they publish their report to the public, and we look at how are they doing quarterly. Are they up in revenue? Are they down in revenue? How is their stock? Is their stock going up? Is their stock going down? For instance, social media sites, they oftentimes report quarterly their active user base. So recently, Facebook published that they have 1.23 billion active users. That's 1 in every 7 people on the globe. Okay? On the globe. Yeah. So we make these comparisons. We make these comparisons. Other ways we make these comparisons. Let's say you're preparing food. Okay? You're comparing food and you have meals. All right? Well, you might say that you have a ratio of mouths to plates. So if you don't have enough plates per mouth, well, then you say, hey, you two, share this. Okay? So you take the corn, I'll take the mashed potatoes, that person takes the roast beef, we split it up nice and evenly. Okay? Or the roast beast, if you are a Seuss fan. These are ratios. Now, here is where we make comparisons. We make comparisons, but you're not always going to be asked to write it like this. For instance, you might be asked this question. Okay? Let me go ahead and write this out. How much, or let's see, how many, let me put it this way. How many times taller is Mr. B than LS? How many times taller is Mr. B than LS? Is this still a comparison? Is this a comparison? Okay, it's a comparison. What are we comparing? Yeah. Okay, this word taller indicates that we're comparing what value? Height. Yep. Okay, so there's definitely still a comparison here. We are comparing height. So I'm going to emphasize this. Okay? And because there is a comparison, we will turn to this idea of a ratio. So we have to ask ourselves, how do we answer this? They're not looking for a ratio. They're not looking for the ratio of my height to LS height. They're looking for, they're looking for a single number. They're looking for a single number. How many times taller is Mr. Bornheimer than Landon? So what we do, is we need to figure this out. The answer to this is you turn to the fraction, that's presented, and it is 5.92 feet over 5.25 feet. What do we do here to get a single answer representing how many times taller is Mr. B than Landon? Yeah. Right. Exactly. So I'm going to divide. And here's the trick. We could have asked how many times shorter is Landon than Mr. Bornheimer, in which case then we'd flip the numbers. So you have to be careful. Order does matter. How many times taller is Mr. B? In this particular case, the larger number goes on top. And we'll do this step by step. So divide these two numbers, 5.92 by 5.25. Divide these numbers. And Dylan, what do you have? 1.13. So 1.13 times taller. However, had I reversed it, I could have said something along the lines of how many times shorter how many times shorter is LS than Mr. B? In this case, because we're going smaller, our ratio or our answer should be less than 1. So that case, if we're going larger, if we're comparing something, we're looking at how many times larger something is, we want the large number on top. If we're looking at how many times smaller something is, we want the small number on top. So in this particular case, it would be reversed. In this particular case, it would be 5.25 divided by 5.92. And Liam, what's the answer? Let's go. It's not 99. 0. Let's go. Shh. For the sake of time, we'll focus here. This is how many times shorter. Not much. Not much. He's about 0.9 of my height. If you take my height and multiply it by 0.9, you'll get Landon's height.